Assalamualaikum. My name is Hassan Shan and I'm a tutor at Valeem. I'm about to start my recording of this demo lecture, so please proceed with me. Right. So about myself, I'll just give a small introduction. I've completed 7 O-level Cambridge subjects from UAE in 2016. Then I have completed 4 A-level subjects, math, physics, chemistry, and biology, also at UAE in 2018. And in the same year, I've also completed my SAT exams for math and physics. Currently, I'm living in Karachi and studying here at Bahria University, Karachi, and completing my degree in computer science. I'm at my 6th semester there, by the way. And work-wise, I have about 5 years worth of experience as a tutor. And I've also been tutoring online for the past year. About the topic today, I'll be teaching AS level maths. And the first chapter, which we normally learn from our P1 papers, are algebraic expressions. So it's just a very small introduction towards the basics towards this chapter as well. Going forward, this will be our content in our presentation. Firstly, I will do a prior check. That's basically where I will revise some concepts that will be used from our O-level classes. And as we move along, I will talk about a few chapters like the laws of indices, factoring expressions, and later on, I'll talk a little bit more in advanced details of complex indices. So here we are at our prior check. So let me just draw my pen out. Our first question here is basically ask us to simplify this expression. Once you see an expression like this, I want to ask you to simplify it. You need to look at like terms. Like terms can be anything that have the same symbol, basically. So right now, my first term here is 4m square n. So I need to find any other term that has the same symbol of m square n. Those are my variables here. So let me just circle around for m square n. And let me see if I can identify anywhere else where I can see an m square n. And I can see one right here. In both these cases, it's 4m square n minus 2m square n. So I can simplify that, add those two together, so I can get 2m square n. And then we can see the remaining terms as mn square, then I have plus mn square, and then a minus mn square. Or I'll add those like terms together, and then you will get your answer, which will look like this. We solve the next question similar to what it was to how it was done in A, and you get an expression like this. Question 2 talks about using single powers, and it briefly talks about how we use the laws of indices. So the first one here, if you memorize the first law, here you would know that the answer would be 2 raised to 5 plus 3, which would mean it will be equal to 2 power 8. The next one is 6 square divided by 2 square. So it would mean, so the answer would be 2 power 6 minus 2, which will give us 2 power 4. And the last one would be, since the whole expression is raised to the power of 2, it means it's going to be equal to 2 raised to 3 multiply 2, which is going to be equal to 2 power 6. 2 power raised to 3 multiply 2, by the way. So yes. Next question is quite simple. We have to expand. That means we have to multiply the constant value, which is outside the bracket, with all the terms inside, and try to see if we could simplify it if necessary. So after expanding the first expression, we will get 3x plus 12. The next expression would be 10 minus 15, because 5 multiplied 2 and 5 multiplied minus 3x. And the last expression would be 12x minus 30y. The fourth question talks about the highest common factor, basically talks about how we had to figure out which is the highest common multiple between the two variables or constants. Our first expression here, 24 and 16, what's the common number between them? If we take the HCF between both these numbers, we would find out that the answer would be 4. Sorry, I'm sorry, 8. And the next one here, since both 6 and 8 are even numbers, they come in table 2, and we also have a value x. We have the common variable 2x. The last one, we have 3 and 4. 3 and 4. 3 and 4 cannot be, they're not in either table, but we do know that at least both these variables, they have an x and y. So we can take an x and y common, and we can say that x and y is a common factor between both of them. The last question is very simple. It's asking us to simplify. So basically, we should look at both the table, look at the similarities in the tables and see if we can simplify the denominator or denominator. The first one would be 2x. The second one would be 10x. And lastly, it would be 5x by 3. And because the last one, it comes in table, excuse me, it comes in table 6. No, let me just think, maybe 8. I'm sorry, it comes in table 8. So we can take out 8 from both the terms, and then we're left with 5x by 3. Moving on, we are now talking a little bit more about the laws of indices. We can use the laws of indices to simplify powers of the same base. The same base basically means if we're saying 2 to the power m, or 2 to the power 3, or 2 to the power 4, multiply 2 to the power 3 to the power 4, or anything else. That base is actually 2. And that power, it can be any other unknown variable, but unknown real number. Multiplying two powers that have the same base but different power, we can simply add the powers together with the same base. That's the first law. The second law is a division law, or in other words, the quotient rule, where if the bases are same and the powers are different, but while you're dividing them with each other, you should this time subtract the powers together. So in this case, a power m divided by a power n is actually a's power m minus n. Moving on, this is the multiple rule, the product rule. So a power m whole raised to power n is essentially saying that it'll be a product of the powers. So it's going to equal to a power m times n. Lastly, if we have ab raised to n, where a, b are unknown variables, it will equal to an times bn. Now this is very important. Supposedly, if you're given the expression, let's say 4x raised to power 3, if you want to open that bracket, it will basically mean 4 power 3 times x power 3. So it will be 64x cubed. Moving on, here are a few examples. So x squared times x power 5, that will basically equal to x power 7. Moving on, here we have two same bases, but different constant values. Firstly, let's take the multiple expression of 2 and 3, that will be equal to 6. And we add the powers for r. That will mean it will be equal to 6r power 5. Moving on, b power 7 divided by b power 4 is going to equal to b power 7 minus 4, which will equal 3. Same thing over here. We simplify the expression here because now, let me just draw this. We're now going to divide 6x power 5 divided by 3x squared, 3x cubed. 3 and 6. 6 comes in the 3 table, so we can take out 3 from 6. So dividing that, cutting 6 off, you'll be left with 2. And now, since we know the laws of indices, x power 5 will now be equal to x power 5 by x power cube will actually now equal to once it cuts off, we're left with 2. So that means we're left with 2x squared, because 5 minus 3 is going to equal 2. Which would, yes. Lastly, since we have a product rule here, now here we have to be careful. Here, I would like to revise something about board mass. Board mass talks about how you should first solve whatever's in the bracket, then the order, which talks about the power of indices, and then division, multiplication, addition, and subtraction. So B comes first. So solve what's inside B, and that is our bracket. So we should use we will look at the bracket side of this expression, which is a power 3 whole power 2. So this whole expression will now have to equal, first equal, yes, a power 6 multiply to a power square. And then using the first law, we will be left with 2a power 8. As it is done here, and our answer is 2a power 8. Lastly, same concept here, but this time we're doing in the division. Open up the bracket first, but now since we have 3 inside the bracket, so remember we should take 3 cubed and multiply x squared times 3, x power 2 times 3, and then divide by x power 4, which would be 9 x power 3, x power 6 divided by x power 4. So that will give us, yes, I'm sorry, 3 cubed is 27, yes, which will give us 27x squared. Moving forward, expand and simplify if possible. So we have to expand the bracket. That means we should multiply whatever is outside the bracket with whatever is inside the bracket for both variables, for both terms, and rearrange as you move. For the first expression, it's quite simple. It will come out like that as minus 3x times 7x, and minus 3x will multiply minus 4, and then we'll get our answer like that. Next we have y squared bracket 3 minus 2y cubed. So y squared will multiply 3, which will give us 3y squared, then y squared will multiply minus 2y cubed. And using the laws of indices, it will become y power 5. Moving forward, this one is quite complicated because now we have to multiply the variable 3 times. We have to multiply whatever's outside with all the terms inside, which is going to be 3 times. Since 4x will multiply 3x, then 4x will multiply minus 2x squared, and 4x will multiply 5x power 3, which would multiply and give us these terms here after rearranging the whole thing. And lastly, first we expand the brackets for both of them individually and then simplify them together. So for the first side, let's look at the left side first, which is 2x bracket 5x plus 3. So 2x multiply 5x, which will be 10x squared, and 2x multiply 3, which will give us plus 6x. That's on one side. On the other side, we have minus 5 outside and 2x plus 3 inside. So minus 5 multiply 2x and minus 5 multiply 3, which will then add up and simplify to this expression here. And there you go. Now we have fractions. Here is where you have to be careful. Remember when you did your O-level papers, when you were told to solve the addition of 2 fractions without using a calculator, you would normally come across this kind of problem. Supposedly, if you have a by c plus b by c, this would automatically mean a plus b divided by c. Here you'll have to use the same concept again. You'll have to split the denominator to open up this thing and then re-simplify our equation once again. So it would mean it would look like this. Since 3x squared is the common denominator for both these terms, split them for both of them and simplify them accordingly. So 7x divided by x cubed. So that would mean 7 minus 3 based on the logarithm indices. So our first term would be have x power 4, the next x power 4 plus, which is going to be x power 4 divided by x power 3. So 4 minus 3 based on the logarithm indices, of course. That will give us x. And if you want, you can further simplify by taking x common from both sides. You can have x bracket x cubed plus 1. But it's not required in this sense right here. But it's always good to do that in the exam. Similarly, that's how we would solve in this question here. Split the denominator and simplify accordingly. The first side will have 3x by 2, while the other side will have minus x power 4, minus 3x power 4. Last question is done also like that. Split the denominator and simplify accordingly. You will be left with 4x power 5 plus 3x. Now we will talk about some quadratic equations and some expand and factoring methods. In our first example here, we are told to find the product of two brackets. It's a very simple method to do. Back in our O levels, what we would normally do is we would take the first term here, let that multiply with the first term of the next bracket, and also let that multiply with the second term of the next bracket. And we will draw these arrows to help us guide where we're going. Next, we will take the second term of the first bracket, multiply with the first term of the second bracket, and then let that multiply with the other term of the second bracket. And as you do, you write those answers down, which should be x squared plus 7x plus 4x from the second term, plus 7th 4s are 28. And as you simplify further, you will get x squared plus 11x plus 28. Let me just rub this off. Another method is where you would actually draw a Punnett square and write the terms of the first bracket on the top and the second bracket's terms on the side, and take a cross product of each term and add them up and try to simplify them as you go, which would look something like this. There are many methods to do this, but overall, do what you feel comfortable with. Take the terms of the first bracket on the top side and the terms of the second bracket on the side, and take a cross product. X multiply x, x squared, plus 4x times x would get us 4x. Then next we have to take a multiplication of x into plus 7x, plus 7 which will give us 7x. And lastly, we'll have to take multiplication of 4 into 7, which will give us 28. The last step is to write down all these terms and try to simplify them to get our quadratic equation. Similarly, that's how we do for the next one. Take the terms of the first bracket into the top side, while the terms of the second bracket into the next side. So 2x and plus 3 comes on top, while x and minus 8 comes on the side. And moving on. Take the cross product of each term and simplify them as you move on. We'll get something like this. Now, this is something quite complicated sometimes. It can actually be quite overwhelming once you see something like this, but it's nothing too complicated. It's quite simple to understand. It only involves one thing, taking one problem at a time. Right now, you understand how to expand an expression. You understand how to expand an expression using two brackets. So take any two brackets in this three bracket expansion. I will take this first two, get the quadratic equation that you would normally get, that I'll just write here as a question mark for now, and let that multiply with the next term as x plus 3. And once you get all the terms here, you'll get about 6 terms. Add them up, simplify them up, and that would be your final answer. Let me rub it off and let me show you. Take any two brackets. After expanding them, after simplifying them, we will get this. And let that multiply with the next bracket, which is in our equation. We will get that. And it doesn't have to be these two terms. It can be any of the terms, any two brackets. Overall, you'll end up with the same answer. As you move along, let x multiply with the first three terms of this big bracket, and then 3 multiply with the first three terms of the next bracket. You'll get about six new terms, and then you'll have to add them all up. Once you simplify them, it will look like this. Now, if you look here, you're getting a cubic expression. Now, if you multiply with two brackets, you're going to get a quadratic expression. But if you multiply with three brackets, you're going to get a cubic expression because you're multiplying the value x on x on x 3 times. So x into x into x will basically give you x cubed. And obviously with some constant terms if they will be in the expression.